trigonometric ratios of multiple and sub-multiple angles, and something is written over here, that is integral multiples 2a, 3a and 4a, and something is written there. We will go for it. That is, assume that theta is an angle, and the integral multiples, that is 2a, 3a and 4a and so on, are called the multiples of a. They are the multiples of a. The integral multiples like 2a, 3a, 4a, so on. Like that, we have, they are called multiples of a. And multiples of a by fractions, if we write them by fractions like 1 by 2 and 1 by 3, they are called submultiples of a, and that is multiple and submultiple angles. And let's go for some of the formulas in multiple and submultiple angles, and they are, first one we will go for sine 2 theta or sine 2a, and we can, for the easy remembrance purpose, we'll use sine 2 theta. And sine 2 theta is equal to 2 sine theta cos theta, and in terms of tan we can also write 2 tan theta by 1 plus tan square theta. And coming to the cos 2 theta is equal to cos square theta minus sine square theta, and we have many formulas like that. That is 1 minus 2 sine square theta and 2 cos square theta minus 1. And from this single formula we can also derive many of the formulas. And next, in terms of tan, we write 1 minus tan square theta by 1 plus tan square theta. That is cos 2 theta formulas. And while coming to tan 2 theta formulas, that is 2 tan theta by 1 plus tan square theta. How we get that? That is sine tan 2 theta is equal to sine 2 theta by cos 2 theta. That is, what is the sine 2 theta in terms of tan? That is 2 tan theta by 1 plus tan square theta. And cos 2 theta formula, that is 1 minus tan square theta by 1 plus tan square theta, and this will be cancelled, and we ultimately get 2 tan theta by 1 minus tan square theta. And when we come to cot 2 theta formula, that is cot 2 theta is equals to cot square theta minus 1 by 2 cot theta, and the ultimately reciprocal of it, cot is 1 by tan. And this all are the formulas of trigonometric ratios regarding multiple and submultiple angles. And next we will go for trigonometric ratios of compound angles, and let's go for it. We will go for trigonometric ratios of compound angles, and here is a term called compound angle. What is a compound angle? Simply we can tell as the sum or difference of two or more angles is called a compound angle. The sum or difference, or we can also call as a algebraic sum of two or more angles is called a compound angle. And this is a general, these are all the general definitions of compound angle, and let's go for it. And first one is sine A plus B, and that is sine A cos B plus cos A sine B. How to remember it is, first sine A plus B, it is plus and here comes plus, and the alternate functions like sine and cos, that is sine A cos B, sine A cos B, cos A sine B, A B, and next we have sine A minus B, that is sine A cos B minus cos A sine B. And next it is also same to remember, minus and minus. And third one is cos A plus B is cos A cos B minus sine A sine B. And we have cos at one side and sine at another side. And if we have plus when coming to cos A plus B, if we have plus in the middle, we can remember as minus, and this is only for the remembrance purpose. If we come to proofs, we have another video, we will do another video for it separately for learning all the proofs. And while coming to cos A minus B, there is cos A cos B, that is opposite, that is plus sine A sine B. Okay friends, that is, here it is minus, so we kept plus. And coming to tan A plus B, that is tan A plus tan B by 1 minus tan A tan B. When we have plus here, we have plus, and alternate to this is the denominator minus. And coming to tan A minus B is tan A minus tan B by 1 plus tan A tan B. And same here also, minus and minus for the numerator, and while coming to the denominator it is alternative plus. And coming to seventh one, that is cot A plus B, that is cot A cot B minus 1 by cot B plus cot A. And this is opposite. When we have cos, opposite plus to minus and minus to plus, here also we can remember plus to minus and minus to plus. And this is minus in the numerator, and alternative this is plus in the denominator. And coming to cot A minus B is equal to cot A cot B plus 1 by cot B minus cot A. And we can remember it very easily. Here it was minus and here we get plus. And alternate to this is minus. And next we will go for the positive angles of which are represented in our quadrant and quadrants, that is in a coordinate system or Cartesian system we call it. And let's go for it. Coming to this Cartesian system, and the different angles which are positive and the different trigonometric ratios which are positive in each of the quadrants are given by our Cartesian system or coordinate system here. And let's start it. Here we have 0 degrees, and here perpendicular we have 90 degrees here, and plus 90 gives us 180, 90 plus 90 180, and plus 90 will give us 270 here, and again plus 90 will give us 360 degrees. So we also have a trick here. All silver tea cups, or all students take calculus is our trick here, and easy to remember this. And when all the angles are measured from here, and coming to this is first quadrant, second, third, and this is fourth. In our first quadrant, the angle is the theta. The angle is between 0 and 90 degrees, and we can represent it as 0 degrees less than theta less than 90 degrees. Because of this, we can represent this also, and 90 degrees less than theta less than 180 degrees, because the angle is less than 180 and greater than 90. And next one is the angle is less than 270 and greater than 180. So 180 degrees less than theta less than 270 degrees. And here also we have 270 degrees less than theta less than 360 degrees. And we can represent it as 90 minus theta. Why we can represent 90 minus theta? Because the angle which is represented in the first quadrant is less than 90. Less than represent minus, so we represent it as 90 minus theta. And here we represent 90 plus theta, because the angle is greater than 90 and less than 180. Here is our second quadrant, so we represent it as 180 minus theta. And third quadrant, 180 plus theta and 270 minus theta. And next is 270 plus theta and 360 minus theta, because 360 the angle which is represented in the fourth quadrant is less than 360, and in the first quadrant it is more than 360. 360 plus theta. And one more thing about this is, if the angle which is represented on the x-axis, there becomes no interconversion. Like sine to cos and cos to sine, this will not interconvert. So the angle which is represented on x-axis will result in no interconversion, and which is resulting in y will have vertical line, that is the intersection takes place. Interconversion takes place. That is sine to cos, cos to sine, cot to tan, tan to cot. And this is the end of this video, and thank you friends, thank you for watching this video. And in this next video we are going to derive every function with this angles. And thank you friends, thank you for watching this video. All the best, study well.